now we're ready for part 4 of the lab, conservation of linear momentum during a elastic collision. So I've written up here, this is the formula that we're going to use for an explosion, where one thing turns into two things. This one is the formula for the collision, in which we start with two things and we end up with one thing. And now we want to do two things that are going to collide, but they're going to bounce off of each other. So that's going to be the elastic collision. And also energy also has to be conserved. So we're going to do a perfectly elastic collision, which means that no energy is going to be lost during the collision. So it begins with a certain amount of energy, and then it ends with a certain amount of energy, and no energy was turned into heat. So that's going to be called a perfectly elastic collision. So that's the situation that we have here. So we're going to go to the simulation, and this time we want the elastic collision. So that's going to be this one. And so let's just go ahead and hit the go button just to show you what's going to happen here. So they come together and then they bounce off of each other. Now be very, very careful about this. So let's see if it does this. Well, it didn't. Sometimes what happens is that the red car, when it gets over to here, the negative sign is obscured for some reason. So just remember that if the car is going in that direction, it's got to have a negative value for the velocity. Okay, so now let's go back to the lab here. And let's look at the formula for conservation of linear momentum when it is a perfectly elastic collision. And do you notice that it's kind of a hybrid of these two? So that this one had mass total here and mass total over here, but this time we're going to start out with two objects the same as the inelastic collision. So we're going to have M1 V1 initial plus M2 V2 initial. And remember that M1 could be like red and M2 could be blue. And then it's going to equal, okay, now they're going to hit and then bounce off of each other. So it's going to be M1 V1 final plus M2 V2 final. So it's kind of a combination of these two all put together. So this one is the most complicated of the three because you've got four things that you have to be worrying about. In these other ones, you only had 1, 2, 3, 1, 2, 3, but now you've got four pieces that you have to take into account. So we're going to give the carts these initial conditions, a mass of 2 for the red one, a mass of 3 for the blue one, an initial velocity of 2 and -5 so that they're going to collide. And then you're going to calculate the initial momentums, remember using this up here, and then you're going to find the final momentums from the simulation. So you're going to get that from here, and then you're going to calculate the final momentums. So you're going to get the final velocities from the simulation and then multiply this number here by this mass over here, and then that will be the momentum that goes here. And you'll do the same thing for the blue, and then you're going to add them together and then compare this number with this number. And so you're going to look at what was the initial momentum of the system, and then what was the final momentum of the system, and then was momentum conserved, and you'll answer that. All right, now we're going to make it harder. So this time you've got the initial masses you got the initial velocities. You're going to measure the final velocity of the red one from the simulation. Don't look at the blue one. Then you're going to use this formula, so you'll know this and this and this for the red one, but you won't know this one. So the goal is going to be to calculate that velocity. And then once you calculated that velocity, compare it to what the simulation says. And how do you think they should be related? They should be the same. So hopefully they will be the same. Okay, lab questions. So what was the purpose of the lab? So copy and paste. What is the definition of linear momentum? What does conservation of linear momentum mean? Okay, what was the difference between an elastic collision and an inelastic collision? So what's different about what happens when they hit each other? Number 5, you have a 500-gram cart is moving at this speed. So what is its linear momentum? And then watch the units, because this 500 grams is not the correct unit. So you should know what the official metric unit for mass is. So convert that to the official metric unit before you calculate the momentum. Number 6. So you got Jack and Jill. So I give you the mass of Jack, I give you the mass of Jill, and they're ice skating. They're both at rest when Jack pushes against Jill. So they're together, and then one of them pushes against the other one, so they're going to start to move away from each other. He moves backwards with the velocity of this. Now notice that I didn't put a sign convention on there. So you need to figure out which one's going backwards and which one's going forwards. And then that's going to be important because that determines the sign. And then calculate what's going to happen to Jill. So I need to know her velocity and in what direction is she going to go. Okay, now we got question number 7 here. A 250-gram cart is traveling to the right with a speed of 0.31, and it's going to collide inelastically with a 500-gram cart traveling to the left with the speed of that. Now I did not put the sign convention in there, so you should know how to handle that. Calculate what their combined final speed would be. So you're going to use one of these 3 equations in order to solve the problem. Number 8, a 9-kilogram bowling ball races down the lane at this speed, and it strikes a bowling pin which is at rest, and it has a mass of 0.85 kilograms. If the pin bounces backwards with the speed, so what do I mean by that? So let's say that the ball is going in this direction, and then here is the pin. Okay, so the pin is going to bounce in this direction. It's going to go backwards. And so then what is the velocity of the bowling ball after the collision, assuming it's elastic? So you're going to know this speed, you're going to know this speed, so this is the before, and then afterwards you're going to have the ball, which is going to have a certain speed, and then the bowling pin is going to be knocked backwards. So the question is, what would be the speed of this bowling ball? And again, you're going to use one of these three equations in order to solve it. So I hope that you learned something about linear momentum, and I hope that you'll come back for another Introduction to Physics lab. So until then, bye.